soils and rocks. An engineering geologist must, of necessity, be sound in hydrogeology. We have employed the most sensitive techniques to look for groundwater in Nigeria, and we have been able to notice that if you are able to map lineaments and photolineaments, we can have an idea of the groundwater yield, where we can do more detailed investigation. We have also employed geophysical techniques, even in difficult geological terrain, to locate promising boreholes. Foundation investigation for structures. Appropriate design of foundation for any structure requires integrated use of geological, geophysical, and geotechnical methods. This is the approach in developed countries of the world. However, subsoil investigation for structures in Nigeria is usually limited to in situ geotechnical tests and sampling from boreholes, since only civil engineers are usually but not always involved. Even then, the investigations is often limited to structures built by governments and multinational companies. No wonder we witness incessant cases of building collapse, dam and road failures. Data garnered from only geotechnical investigations are often not adequate, for it may not either be economical or feasible to execute penetrometer tests at many points and or sink several boreholes. Geotechnical data obtained from surface geophysical surveys have been found to be reliably close to those garnered directly from boreholes. Olayinka and Olayiwola, 2001. Surface geophysical surveys are fast, efficient, and cost-effective in obtaining data that can complement geotechnical parameters for foundation design for structures. Two major parameters are often employed in foundation design for structures. These are their liable bearing pressure and settlement. Differential settlement is more critical than total settlement, and this can be responsible for distress or collapse of structures. Detailed subsurface exploration is required to generate reliable subsurface models at a site for any proposed structure, and if we do this, we can avoid differential settlement. This was similar to what Olorunfemi method did in 2005 when they used geophysical survey to determine subsurface models around a dam, around a building that was about to fail, and they were able to notice that the soils there are heterogeneous from corner to corner. If we adopt a purely geotechnical approach, we may not be able to get these details. Highway geotechnical classification of subgrade and subbase soils. The major components of a typical flexible highway pavement from bottom to the top are the subgrade, the subbase, the base course, the riding surface. Stability of flexible highway pavement have been shown to depend on clay mineralogy, major oxides geochemistry, and geotechnical properties of both subbase and subgrade soils. And these can be used to evaluate highway subbase and subgrade soils. Adeyemi, 1992, has shown that the degree of stability of the Lagos-Ibadan highway pavement increased with the amounts of kaolinite, ferric oxide, CBR, and a confined compressive strength of the subgrade, that is the foundation soils. Adeyemi et al. 2003, who tested soils around Bergan Junction, Ibadan Ife Road, we are able to establish some mathematical models between the amount of kaolinite and some geotechnical parameters. Many standard geotechnical specifications established for temperate zone soils have been found not to be applicable to tropical soils. There is thus the need to evolve standards for our soils. However, Maldedo, 1983, has recommended maximum linear shrinkage of 8% and 10% for highway subbase and subgrade soils, respectively. Our studies over the years have confirmed that Maldedo's specifications are reliable. Laboratory tests of lateral soils require special approaches that are different from those of temperate soils. And Maloma was able to determine what we call mechanical and stability characteristics on soils from Brazil. And we have noticed that on many of our soils in Nigeria. And this means that when we are testing our soils in the laboratory, we must adopt special approach that will enable us to correctly assess the soils, so that we don't say a soil that is fine-grained is coarse-grained. If you use such a soil for construction, the road is likely to fail. Although permeability is not a routine parameter for evaluating highways of grades and sub-base soils worldwide, I have been determining this parameter in characterizing highways of base and sub-base soils. And we have generated mathematical models for estimating permeability of laterite soils from grain size and consolidation through compressibility parameters. When an impervious or low permeability soil is in contact with water as a result of poor drainage and exposure to the surface, the water will stay in it for a long time, thereby weakening the soil rapidly. A small hole on the pavement will thus become rapidly widened and eventually become a pothole. This is the case with many sections of Ife Band carriageway of Ibadan, Ife Highway, and we have noticed this around the Magan area, where we have a pothole that is filled with water. And we can avoid this if we use coarse-grained soils and we provide adequate drainage on our highways, especially during construction. Laterite soils have been found to exhibit wide variability in properties even within a very restricted area. Ogunsawo, 1985. Adeyemi and Wahab reported significant variation in the grading, plasticity, and severe characteristics of subgrade soils from a village called Awosun near Ile-Ife. And the samples we are taking within a distance of 39 meters, and we have been able to establish significant variation in most of the geotechnical properties of the soil. Field samplings of subbase and subbase soils must therefore be very comprehensive in order to avoid making wrong inferences from data obtained from laboratory tests. Shallow depth water table has also been found to be responsible for road failure. Continuous inundation of subbase and subgrade soils by groundwater can increase in plasticity and weaken its strength. And when such a soil is loaded, it can undergo permanent plastic deformation that often results in development of waves. And waviness, according to Gidigasu, 1976, is the commonest form of road failure in the tropics. A typical laterite profile shows that the soil immediately above the fresh rock is saprolite, overlain by multitude horizon, which is in turn overlain by laterite horizon. And when a pavement is founded on saprolite horizon, it is not likely to last. And this is the case in most of the roads that we construct nowadays, unlike the one constructed by Awolowo many years ago. And this is why our roads don't last. We have noticed this around Magan, a village called Majeroku. Surface geophysical surveys coupled with field compatibility boreholes can help in generating subsurface models. We can also use this to identify locations with shallow depth to water table. Mr. Vice Chancellor, sir, our road needs not just a hatch, but a big one to survive. The small hatch is the regular innovation, while the big hatch is engineering geology. We can save our roads from incessant failure. Subsoil investigation for buildings. Institute tests such as penetrometer tests are usually faster and cheaper than sampling from boreholes. Besides, data collected in situ are much more reliable for foundation design than those from laboratory testing of samples from boreholes. Adeyemi and Osamo, 2001, executed several standard precision tests in 20 boreholes in Lagos and Port Harcourt areas. And when we compare the data with cone resistance, we were able to establish some interesting mathematical models, and we were able to get collision coefficient as high as 0.85. And what this means is that if we cannot afford to sink many boreholes, we can do standard precision tests, we can do penetrometer tests, which is faster and cheaper, and we can estimate some important geotechnical parameters. Our recent integrated geophysical and geotechnical studies of a hypothetical proposed building site at the University of Ibadan has helped in establishing mathematical relationship between resistivity and some geotechnical parameters, such as persistility and bulk density. We have been able to establish interesting equations. Subsoil investigation for dams. Since failure of a dam can be highly catastrophic, leading to loss of lives and property, detailed geological, geophysical, and geotechnical investigation should be carried out. We have executed subsoil investigation around the proposed arch dam across River Awena, Kajola village near Ilefe. And we were able to sink several boreholes, and many of these boreholes extended to rocks. And we determined an important property of rock, which we call rock quality designation, that are very high. And this indicates that the rocks are not fractured. And coupled with some other geotechnical tests that we performed, we were able to recommend the location for dam construction. We also conducted integrated geophysical and geotechnical investigation around the proposed dam sites across River Ewawa, near Okada village, Edo State, Akelabi 2011. And we were able to establish interesting correlations between geophysical parameters and geotechnical ones. And in fact, the depth that we got from geophysics agreed very well with the actual depth. Environmental geology. Environmental engineering geology. I have been involved in environmental impact assessments through auditing for many organizations in many parts of southwestern Nigeria over the years. In collaboration with my students, I have investigated many locations for their suitability or otherwise as landfill, that is, waste disposal sites. Emphasis has been on classification of laterite soils for landfill sale using mineralogical and geotechnical parameters. Geophysical surveys have also been used to generate subsurface models with special emphasis on depth water table. Adeyemi 2011 and 2011 A and B employed geophysical and geotechnical methods to classify the sites in Ibadan, University of Ibadan for landfill. And the results of our geophysical investigation, geotechnical tests, from the results, we were able to confirm that location can be used for construction of landfill. We employed geological and geotechnical techniques to evaluate an active borrow pit at the outskirts of Ozubulu along Onitsha-Owerri Road, eastern Nigeria, for possible use as landfill. Adeyemi et al. 2012. The determined amount of clay size fraction, plasticity index, coefficient of probability, and clay mineralogy confirmed that the location is good for construction of landfill. I have been involved in several environmental impact assessment studies in many locations in southern Nigeria. The most recent one was done for a community in Maniya area of Ibadan. Members of the community took a quarry site operator to court after they had suffered negative impacts on their buildings, which they linked with the quarry operations. On Friday, 1 February 2013, I was in the witness box in the High Court of Oyo State as an expert witness for about 30 minutes before I was discharged. Environmental hydrogeology. This field of geology is concerned inter alia with the influence of man's activities on the quality of groundwater. Wells are dumps, while underground wells are located with little or no regard to position of septic tanks. Odukoya et al. 2004 studied 12 water samples around West African Portland cement in Shagamu. And we were able to notice that the soils and water have been negatively impacted by the rock and the activities in the area. Our study of the chemical composition of 20 underground wells, water from Ogumasho, confirmed that anthropogenic, that is those that have to do with human activities, factor has stronger influence than geology on the quality of groundwater. Adeyemi et al. 2012. Our ongoing investigation around Lakwite waste dump near Maniya, Ibadan, Oyo Road, arguably the largest and most active in Ibadan land, has revealed thick overburden soil of low permeability above fresh rock. Geochemical properties of hand-dug well water samples have been found to improve as we move away from dump sites, especially on the downslope section of the area. And this indicates that the waste dump site is negatively impacting on the groundwater in the environment. Environmental petroleum geology. The geological consultancy unit of the then University of Ife did extensive geophysical and geological investigation for tar sand in Okutupa area, and we have been able to do a follow-up investigation, and we have been able to confirm what they did. They told us that bitumen can occur in 2 subsurface horizons, and we have been able to confirm that. We have gone ahead to indicate that we have confined aquifer above bitumen horizon. And what this means is that we have to be careful of blowout when we are exploiting bitumen. We have confirmed from geotechnical investigation that most of the locations that we can mine bitumen without actually having negative impact on the environment. In fact, we have also been able to do organic geochemistry, organic geochemical analysis, and we determined polycyclic aromatic hydrocarbons pH, which average was found to be 0.08 milligram per kilogram, which is generally lower than the maximum figure of 0.10 milligram per kilogram stipulated in the United States Department of Health and Human Services Cancer Risk Evaluation Guide, Akimosin 2009. By and large, there are no adverse geological baseline characteristics that could prevent both open cast and deep mining of tar sand, otherwise called bitumen, in the Okutupa area of southwestern Nigeria. Community development. During my tenure as acting head, Department of Geology, we executed integrated geological, geophysical, and geotechnical mapping of Ajibode. The generated geological data, hydrogeological and geotechnical, are invaluable for planning and development. And we are able to construct drains in the department that has put a permanent stop to perennial flooding of the department. In fact, when Professor Adeyemi.Engineering gave his inaugural lecture last year, the second day there was heavy flood, and my department was not impacted at all by the flood. We bless God for this. The Departmental Geotechnical Consultancy Committee, headed by me since the year 2012, has executed some soil investigation for many proposed structures within our campus. The most recent one for the university was the geotechnical study to ascertain the cause or causes of distress of a building block in Awolowo Hall. The students have been asked to leave that block, and will soon come out with our report. Conclusions and recommendations. Mr. Vice Chancellor, sir, I have endeavored to present substantial aspects of my contributions in the field of engineering geology since 1987. Together with members of my research team, I have executed many researches on soils and rocks from southern Nigeria. These research works have showcased the relevance of geological sciences in foundation investigation for and construction of structures such as buildings, dams, and roads. In the course of this lecture, I have been able to articulate the following facts inter alia. Engineering geology is important in reliable evaluation of naturally occurring construction materials such as lateritic soils and crystalline rocks. Engineering properties of lateritic soils can be significantly improved by mechanical or chemical means in cost-effective ways. This will help in erecting structures that can stand the test of time. Termite rework soils can be effectively employed in improving geotechnical properties of lateritic soils. Engineering geological input can help in appropriate investigation of foundation for structures and eliminate incessant failure or distress of structures in Nigeria. Nigeria is blessed with abundant soils and rocks, which are similar but not identical geologically and geotechnically. Mathematical models for estimating geotechnical properties of soils and rocks have been generated. Utilization of such models can help in rapid and cheap evaluation of construction materials and foundation investigation for structures. Engineering geology is very relevant in the prevention of environmental hazards such as erosion, slope failure, and flood. Engineering investigation, geological investigation can help in isolating where domestic and industrial waste can be disposed without polluting groundwater. Lateral influence of active waste dump can be reliably determined through engineering geological investigation. Engineering geological baseline studies can help in generating data that can use to evolve environmentally friendly exploitation of hydrocarbons such as bitumen that is abundant in parts of southwestern Nigeria. Recommendations. Geoscientists in Nigeria have to be given their deserved recognition and role in construction of buildings, dams, and roads. This is the case in developed countries of the world, where even a bungalow cannot be constructed until a geoscientist has had an input. Geoscientists must be allowed to work hand in hand with foundation and structural engineers in order to ensure that our structures do not fail. Jesus, the great engineering geologist, described any man that builds his house on a rock as a wise man, and he that does so on sands as a fool. And I quote the Bible, "Therefore, whoever hears this saying of mine and does them, I liken him to a wise man who built his house on the rock. And the rain descended, the flood came, and the winds blew and beat on that house, and it did not fail, for it was founded on the rock." Matthew 7:24-30. This recommendation is in line with an important point made in the communique issued at the end of Nigeria Mining and Geoscience Society pre-conference panel discussion held in Lagos last year. And it reads us: as a result of failure of many roads and collapse of bridges and buildings, governments at federal, state, and local levels should enact and enforce laws that will make it compulsory for geoscientists to be involved from planning to execution stages in construction of roads, bridges, major buildings, dams, and all other earth-based structures. Unquote. Geoscientists need to be more involved in environmental impact assessment, management, and protection. This will help to prevent, reduce natural hazards in Nigeria. Interdisciplinary researches have to be encouraged. Although our university Senate research grant is on ground, we can still improve on this. In view of the importance of lateritic soils in Nigeria, the federal government should establish as soon as possible a center for lateral research at the primary university. Agronomists, soil scientists, geographers, geologists, chemists, zoologists, etc. can execute collaborative research at the center. Our laboratories at present lack functional state-of-the-art equipment. Items of equipment for field and laboratory investigation need to be provided as a matter of urgency. Concluding remarks. Termites, though small, are diligent and well organized to the extent that they build edifices, feed and protect their leaders and members of their territories. This is a challenge to us to unite and work for the progress